Hi, welcome to video 4 on the differentiation topic at higher. Today we're going to look at some applications of derivatives. Okay, so the learn intention here would be to apply differentiation to a variety of contexts. Just put that S in so don't get annoyed. And then success criteria will understand the different ways that you can be asked about differentiation, be able to differentiate those expressions that you're given successfully. Okay, and lastly, being able to evaluate a differential at a given point or time to answer a contextualized problem. Okay, so we've done a lot of work on differentiation, different ways, shapes, and forms. Okay, now it's about using it and how we can use it and what we can use it for. Okay, so this mind map here might be a way of getting a good idea about different ways you can be asked. Okay, so lots of different things that pops up for differentiation. The first ones I'd probably say is derivative and okay, sorry there, my PowerPoint disappeared for a second. Okay, so different ways we can look at differentiation, how we can be asked. Firstly, most common ones, derivative and differential is just different names for the process, the thing that comes out of your differentiation process. The f dash x or f dash 3, just as we've seen. Okay, so if you're asked for f dash x or f dash 3, that's specifically using f dash x at a specific point. Dy by dx we're actually going to look at in the next video in a bit more detail. Okay, just a different way of notating the differential. Gradient of tangent, that's how we first met our differentiation, just as a formula to get the gradient of a tangent to the curve. And this one's probably the one that pupils forget most often. The rate of change, that's just another way of talking about gradient, specifically when it is in a context. The gradient of a specific curve or line is really the rate of change, how fast something's changing. The steepness of a line is how fast that thing is changing. And a very specific example of that would be the relationship between distance, velocity, and acceleration. Okay, so distance, if you've got a formula for distance with respect to time, your speed is how fast your distance changes, so the rate of change of the distance. Therefore, your speed can be d dash t, the differential of distance. And then in turn again, acceleration is how fast your speed is changing, or the rate of change of your speed or your velocity. So the acceleration is v dash t. Okay, so speed is the differential of the distance and the acceleration is the differential of the speed. Okay, so again, we need to be aware of all these different ways of finding and using differentiation. Okay, so we're going to look at a couple of examples. Here, we've got f of x is equal to an expression, a function, and we want to evaluate f dash 4. So seeing the dash in the middle, I know I've got to differentiate, and because it's f dash 4, I know I'm going to need to substitute 4 in to get a specific value. Okay, firstly, before I can differentiate, this needs to be rearranged because there's a root kicking about that I don't want. So to take that square root out, it's going to go to the bottom of my fraction, x to the power 3 over 2, and then I'm ready to differentiate. Okay, so now we're ready to differentiate. So f dash x, this is me showing I'm differentiating. 3x squared, the 2 comes down and makes that 3 or 6. The power will decrease to 1, so just 6x. And then it'll be plus 3 halves x, decrease it by 1 and becomes power of a half. Okay, and this is where it becomes really vital or really helpful anyway to be able to rewrite it. Okay, because that's a power of a half. I'm about to substitute something in, it'd be nice to have that rewritten as a square root. Okay, and then f dash 4 just means to that differential, I'm substituting in 4. So 6 times 4 plus 3 halves times root 4. Okay, so that's 6 4s are 24. Root 4 is 2. Divided by 2 is 1 times by 3 is 3. So it's 24 add 3 is 27. So I'm evaluating the differential at the point 4 and I'm getting the answer 27. Okay, so f dash 4 means I'm differentiating first and then subbing in to get a value. Okay, second question here, we're looking to find the rate of change of h of x at x equals -2. Okay, so rate of change, that's a signal, that means differentiation. So I'm going to have to differentiate h of x here. Okay, it can't be done at the minute because it's written as that big fraction. So what I'm going to do is I'm going to unravel that fraction by dividing each term by x squared. So first one's 1 over x squared, and then minus 4x over x squared. Okay, 1 over x squared becomes x to the power negative 2. And then you've got minus 4 from your numbers, and then x to the power 1 divided by x squared. Taking away your powers gives you x to the power negative 1. Okay, now I'm good to go. So h dash x minus 2 comes down, and then it's x to the power negative 3. Okay, then it's minus 1 comes down and multiplies by the minus 4 to make positive 4, x to the power negative 2. And again, it helps to have this rewritten with positive powers, just in terms of the calculation I'm about to do. So it's minus 2 over x cubed plus 4 over x squared. Just remember that only the things connected to the powers, so in this case the x's will move down to the bottom. Okay, then at x equals negative 2, I'm calculating h dash negative 2. So it's negative 2 over negative 2 cubed plus 4 over negative 2 squared. Okay, negative 2 cubed, well, negative 2 times negative 2 is positive 4 times another negative 2 is negative 8. Okay, and then that'll become 4 over 4. So it will be a quarter, add 1, which is 5 quarters is your final answer. Okay, and last one here. Okay, the distance travelled by a model train over a bridge is described using that formula there, where t is the time in seconds after the train started. Calculate the speed of the train after 6 seconds. I'm given a formula for distance. I need to find the speed. Okay, so we need to know that if you want to find the speed from the distance, the speed, let's keep it as velocity. To get a formula for speed, you need to differentiate the distance. Okay, so this one here, 3t, just becomes 3. In that second term, the 2 will come down, make it 2t over 8. Okay, so 3t minus 2t over 8, which will just simplify to 3 minus the 2 8s will just simplify to 1 over 4, so 3 minus t over 4. Okay, now after 6 seconds, I'm going to calculate v of 6. So it'll be 3 take away 6 over 4, or 3 over 2. So it'll just be 3 over 2. Okay. So looking just back again at our learning session success criteria, we need to be able to understand the different ways that you can be asked about differentiation. That's what was involved in the mind map there, just all the different ways it can be asked. Be able to differentiate those terms successfully, and then evaluate a differential by substituting in a given point or information as part of a contextualized problem. And that's probably the biggest thing that's new here. Okay, thanks for your time.